In this paper, we present a blimp that uses flapping wings inspired from manta rays. Robotic blimps have used propeller motors as a standard method of propulsion. Our blimp agent, Flappy, explores the use of flapping wings as a locomotion mechanism. We take inspiration from one of the most efficient swimmers, the manta ray. Compared to existing flapping wing blimps, such as the Airway by Festo, we explore a low payload agent of less than 150 grams with cheap off-the-shelf components. Flappy uses two balloons filled with industrial-grade helium, providing us with 138 grams of lift. The wings and tail are made of metallized film, and we use carbon fiber rods to support the structure. Servo motors provide the actuation of the wings and tail. The wings follow a sinusoidal velocity profile when they oscillate. Speed control is done by changing the flapping amplitude and frequency, hence changing the thrust generation from the wing. For yaw control, we use this differential thrust generation to turn. Here's a video of Flappy flying straight with a constant speed. Flappy turning by using differential thrust generation in the wings. Instead of a rudder, the tail can be oriented to swing up or down, acting as an elevator. With no forward speed, Flappy will pitch down no matter the tail configuration. But with forward velocity, the aerodynamic forces act on the tail, allowing proper pitch control. Here's Flappy steadily climbing with the tail up. Similarly, Flappy can steadily descend with forward velocity as the tail points down. With an even larger tail, greater pitch effects can be performed by Flappy. The tail shown here is slightly heavier and employs flukes that are seen on whales. Even a backflip can be performed. A thrust measurement device was constructed to measure the time history of the thrust for different flapping characteristics. A parameter sweep identified the optimum amplitude and frequency for each wing. We tested various shapes and sizes to identify their effect on thrust, as well as identify the optimum set of wing shape parameters. We compared flapping wings with a propeller-based agent named Proppy. All components are identical except the wings were replaced with propeller motors of similar weight class. Proppy uses a different balloon orientation to support more stable forward flight. Flapping wing achieves a 68% increase in maximum range, and at similar speeds, flapping wings provide even double the range. We've had the chance to hold several STEM outreach programs with students. From having them create their own wings or making an entire agent from scratch, Flappy provides a hands-on engineering activity. The components are safe to handle and manufacture, and Flappy is still operable even after taking a hit. Thank you for your attention, and please reach out if you have any questions.